Hi friends, welcome back to our channel Education Hub. Our channel, as usual, gives you more lectures and more details about our digital electronics. Today our topic is nothing but sequential circuit. We are right now concentrating not only the sequential circuit, concentrating on little bit view of flip-flop. Another lectures we will provide in this chapter. Right now, we are concentrating on sequential circuit. If you like our videos, please like it, subscribe it, and share our videos with your friends. Don't forget to subscribe our channel and bell button pressing because it is help you to get all the lectures which we will provide. So subscribe, like, share our videos. Let's start with our today's lecture, that is sequential circuit. A little bit sequential circuits related topic you can able to get in this only one lecture. Let's start. And before that, please subscribe our channel. So, let's start the topic, sequential circuit. Sequential circuit in case of digital electronics is very important and it is in several exams comes. Before coming to our topic, let's discuss about combinational logic. The output of this combinational logics depends only on the states of inputs. That means whatever the input you will give, you will get that type of output. It is an example of combinational logic are NAND and NOR gates, inverters, buffers. These four logic gates are the basic almost combinational logic circuits as well as flip-flop. Combination circuits that change the state of the output is known as asynchronous circuit. However, not only asynchronous circuits are combinational logic circuits. So, combinational logic circuits, at a glance, we can able to say its input is only factor for output. Any changes in the states of one of the input will ripple through the circuits immediately. So that is our combinational circuit. Before starting sequential circuit, we should know combinational circuit because digital electronics circuits can be classified two-way: combinational circuits or combinational logic circuits and sequential logic circuits. So, go through the combinational logic circuits. Now, start the sequential logic. Sequential logic has memory. The circuits store the result of previous set of inputs in the current output. It depends only on the input of the past as well as present input. The basic elements in the sequential logic is the B-stable latch or bistable latch or flip-flop, which acts as a memory element of 1 bit of the data. So at a glance, we can able to see sequential logic or sequential circuits, logic circuits, depends on not only our input as well as on the previous output, that is on the memory. Please go through it once. And repeat once more. Combinational circuits output depends only on the current input, has no memory. Okay. So combinational logic is right now clear to everybody, I think. Only depends on current input, has no memory. So it is not at all depends on previous output. Whereas sequential logic outputs depends not only on current input but also on past input values. For example, a counter needs memory to remember the past inputs values. Obviously, whatever the past inputs or past outputs will be, that will be stored and it will be gives you the our resultants. See the circuit diagram of sequential circuit. Here the circuit of combinational circuit, where I am giving the input, coming the output, but here in case of storage elements is there, present states of this output is coming and it goes to as another input to the combinational circuit and it will generate the sequential circuits that we have learned, combinational circuit and now sequential. In case of the sequential circuits, there are two types, synchronous and asynchronous. Synchronous sequential circuits output changes only at some distance or some discrete instance of time. That means within a specific distance oriented time diagram, you will get the changes. This type of circuits achieves the synchronization by using the time signal that is called clock pulse. And in case of asynchronous, the sequential circuits output can change at any time. That means the distance of time diagram will not maintain any time the changes may occur. It is clockless. Let's go through. Every times in our lectures we are giving you some times to go through. If you like our videos, please subscribe our channel, Education Hub. So, what is synchronous and asynchronous circuits? I think right now it is clear to you. Now, after that, what is synchronous and asynchronous? We have to know, we are discussing clock pulse. We already mentioned that. What is clock pulse or clock circuits? Most flip-flops are clocked so that the output change state based on the state of inputs and precisely determined by a times, that means on clock pulse. Uses varies. In this course, flip-flop will be used as a clocked circuit and latches for circuits that are asynchronous. A common clock used in many flip-flop, it may be circuit ensure that all parts of the digital systems change the states at the time, that is depending on the clock pulse, then it will be called as synchronous system. So from this we can able to get that clock pulse is that one which gives you the signaling and synchronization. Let's start. SR latch. Before that I have to tell you, latch means there is no clock pulse occur. It as a two stable states or bistable states. See here, the inputs is given S and R, passes through a NOT gate. S complement, R complement is coming. Now through the NAND gate, where the previous outputs has come as a input, R from S and RS from R. So gives us Q1 and Q1 bar as Q12, Q2. The resultant is there. When S equal to R equal to 0, so S complement R complement equal to 1. Now if Q equal to 0, then 1 and 0 gives us 1, and if it is 1, both ones gives us obviously 0. So you can able to get the first one figure. Similar for second one, it is set and reset, R and S, set and reset. Set to 1, beginning S equal to 1 and R equal to 0, then also you can able to get that. Now I am giving you the same thing with the enable signal clock pulse. If the clock pulse is given, that means right now it is not at all latch, it is becomes flip-flop. So SR latch with enable clock pulse, it gives us SR latch inputs only affects the output states when the enable input is high. So this controls the latch response to its input. The latch hold stored its values while enable input is low. It's called latch. The changes in the inputs during the time when enable is high will affect the output immediately. The circuits is said to be transparent. So again I am telling to explain the diagram. Here just like it is SR set reset latch, the truth table and logic tables is given here. See this. Latches is telling when S equal to 0 and R equal to 0, last Q value whatever we will get, which will be comes as output. And when R is 1, S is 0, then the Q equal to 0. S equal to 1, R equal to 0, that gives us 1. But when both are 1, that will not gives you any output properly. The similar, when the clock pulse is enable, the response will comes just such a way, that is when the response is 0, no matter whatever the set and reset value is given, it will just depends on the last Q. You can able to see there. Now I am telling you the D flip-flop, it is just like RS flip-flop, just one input will be there, set will be normal and reset will comes by a NOT gate. It is also clock enabled, and when R equal to and S equal to 1, then it can be avoided using the input D. It's shown that D equal to, if I give S equal to 1, then obviously R becomes 0 because it is passes through a NOT gate. So please go through the our circuits diagram. It follows D is the input while C equal to 1, that is transparent. When C equal to 0, it will holds the previous value. It is called, just you can see our truth table values. If D equal to 0, clock pulse is 0 to 1, then Q equal to 0 and 1, Q plus 1, 0, 0. It is clear reset. When D equal to 1, clock pulse is just same, that is 0 to 1, then Q equal to 0 or 1, depends on that, we will get Q plus 1, 1, 1. It is called set. So, here we have to say that a flip-flop is simply store the value of D input at the clock transition. The previous value stored in Qn. So, it has no effect unlike other flip-flop. The most widely used flip-flop is D flip-flop. A resistor also developed by using this D flip-flop. It is also called also simple memory or latch. Just go through. Here the block diagram is also given. I think we are able to get. Now another one input flip-flop, that is our T flip-flop or toggle flip-flop. Here the equations is written. If T 0, Q equal to 0, then Qn plus 1 is also 0. T 0, Qn plus 1 equal to 1, then obviously Q plus 1 is also 1. That means it fully depends on Qn. So it is the condition of hold. Just the opposite, when T equal to 1, then you can able to see it's the opposite. So it will be called toggle. Now I tell you once more the SR latch details. When it will comes from 1 to 0 the clock pulse, what will be the resultant come? Here if the S and R both 0, it depends on Qn, that is previous output, so it is called hold. And if it is toggle is 0 1, that means S set equal to 0, reset 1, then it will be clear, because whatever the Qn value it gives us, our previous value, whatever 0 or 1, we will get 0. And just the opposite, when set is 1, reset 0, then Qn whatever, it will always gives us 1, just the opposite. That means it will set you set. And when S and R both are 1, then depend on the Qn, it will not give you any positive value, proper value. So it will be termed as indeterminate or avoidable state. You can able to see from this our diagram. Also here the our block diagram given. Now come to the part of the JK flip-flop. The excitation table of JK flip-flop is similar to SR flip-flop, but doesn't have the problem of S equal to 1 and R equal to 1. When J and K, it will comes to our side, Qn whatever, it will gives you the opposite value, so the toggle is coming. Others, it is just similar with the SR flip-flop. It can perform all the operations, similar types of the SR flip-flop, but only case is that when j equal to 1 and k equal to 1, then whatever the value is comes, depends on that. If qn is 0, it gives us qn plus 1 is 1. Qn is 1, then qn plus 1 is 0. That is the only difference between SR and state. That is the other diagram is also different, but the excitation tables difference will be shown here. Please go through. Here also the block diagram is given. It is also clock enable. The equations is also given. Qn plus 1 equal to jqn plus k complement qn. Just like XOR. I think you can able to get it. Very clear. Idea should be there. Once again repeat. If you like this type of videos, then please subscribe our channel and give our precious commands of your what type of lecture you need. Now our discussion topic is master slave flip-flop. Master slave flip-flop is just similar, where it is SR flip-flop, clock enabled SR flip-flop. 2 flip-flop will be there, but clock pulse is coming, just giving a NOT gate. So when master, first one is master, when the master is active, obviously clock enable, that means slave is clock disable, and just the alternate. When master is disable, that means clock pulse is 0. By NOT gate it is coming to slave, so it will be in active mode. So it gives us just working state. So whatever the values will be goes from master as Y output, it will be goes to slave's input, and when master is sleeping, at that moment our slave flip-flop will working. That means you can able to get that master sleeping conditions is fulfilled. At that moment our slave will start to work. You can able to see this. The state diagrams is given also. SR and clock pulse is also given. When C is 1, master is enable and stored new data. Slave store old data. When C is 0, then master passes the enable to the self. Master is not sensitive of new data, that is disabled sleeping conditions. Then the data will be goes from slave. The state diagram also show you the details. When S equal to 0, R equal to 0, clock is enable, then Q will store the value. When S0, R1, clock 1, it will gives you reset. Just the opposite, when S is 1, R is 0, it gives you set value. When all are 1, that is disallowed condition. And when clock pulse is 0, then whatever the A's are values, always gives you the stored value. That means previous output will be sufficient for that. This is the master slave flip-flop. It is very important. D-type master slave flip-flop. That means only one inputted. Type of positive edged triggered flip-flop. The figure is also given. Master slave flip-flop is such one which is very much important for any type of exam, competitive exam also. So please go through. The slides is also given. D is of master when it is active. Clock pulses always comes through a NOT gate to master, as well as when passed through NOT gate to slave. It's defined logical properties of a flip-flop, such as a truth table does not have any logic gate. Q is the present state of time, and QT plus 1 is the next time, a T plus 1. Let's go through. Here the state diagram I'm giving right now. It will be helpful for you to get an idea what is going on. Check this, where it is given the characteristics of the flip-flop by the diagram. This is just coming to your side, that is S of flip-flops. When S is 0, I repeat it once again to show you the characteristics tables. When S and R both are 1, it will give you the undetermined, undefined and invalid operation. Rest, hold, reset and set values will come. Let's go through it. If you like it, then please subscribe our channel. It gives you a command what you want, need next, and obviously give you a command and like the video. Now I'm showing you the next one. Again, the characteristics tables for D flip-flop. At the end, I'm telling all the characteristics once again to making it proper, to define that you can able to get it properly and can able to remember. Here also set and reset values will come for D values, D flip-flop. The characteristics equation is also given. Let's go through. So from the end of the lecture, I have to show you that what is combinational logic, what is sequential logic, then what is SR flip-flop, what is D flip-flop, what is toggle or T flip-flop, and what is JK flip-flop. We get the brief idea about that. In our next lecture, we will discuss it elaborately. Also, the other sequential circuits will be discussed there. The sequential circuits analysis at the end I am giving once more. The analysis consists that a suitable description that demonstrate as the time sequence of input, output and states. Here the logic diagrams of flip-flop of any kind along with the Boolean equation, state table is also given here. State diagrams I am not showing here, but from there the clock pulse you can able to get that. So in our next lecture also we will analyze that. I will tell you the counter, resistor, the most important part of the sequential circuits will be discussed in our next lecture. So please don't forget to subscribe I think you were able to get this lecture, make you a brief idea about that. You can go through it if you want. I'm giving always the time to go through the slides, not only my bars, because it will helpful for you to get an idea. Now the time of and the ending time is coming for our lecture, today's one's lecture. Next, please wait for our next lecture, mix on counter and register. So once again I am telling, subscribe and like this video. If you like, then obviously press the thumb button as well as subscribe our Education Hub channel. This is the ending part of this lecture. Thank you.